Hi, hey there. Today, or right now, we're going to be talking about linear approximations and just how interesting they are. So, first, let's start off with a little bit of theory. So, what is a linear approximation? First, we have to discuss what linearization is. Um, Now, I'm just going to remind you what the root of linear is, which is line. Linear is just the adjective of being a line. So it's like, oh, that's a line? What a linear line, am I right? Or like, what a linear edge of the table. Ooh. So that's what linear means. So what does it mean to linearize something? It means to make straight, or just to straighten out. So how does that relate to graphs? It usually means making it straight or making it just a straight line. Now, that sounds confusing, but the truth of this is that linearization is none other than just finding the tangent line on a curve. And I'm sure that we can all do that. For example, uh, find the linearization of the function at a. So sine of x at x equals pi over 3. All I have to do is find the derivative, cosine of x, and then cosine of pi over 3 is going to be, I'm just going to put it in the calculator, I'm not going to go unit circle. Okay, cosine second pi divided by 3. It's 0.5, yeah, nice. Not too complex. Oh, there goes sunglasses. This is equal to zero point 0.5. And we know that if we're going to linearize it, it's going to be y minus the x value, x is pi over 3. I mean, yeah, where are we at pi over 3? Sine of pi over 3, 1 half. Oh, it's going to be root 3 over 2, if I'm not wrong. Y minus root 3 over 2 equals 1 half x minus pi over 3. I really hope I got that guesswork right. And that's going to be 1 half x minus, pi over 6 plus root of 3 over 2. So it's going to be 3 root 3 plus pi over 6. That's going to be 1 half x plus 3 root 3 plus pi over 6. Never mind, I was wrong about the pi. It was minus. Uh, Small error, not to be overlooked. But yeah, so I just linearized this function. What does it look like on a graph? Well, let's say we have cosine. Cosine starts from here. Ooh, pi over 3. I can't remember what it's going to be like 1 half. Let's pretend it's right here. And we're going to, actually, no, it's going to be like right here. Yeah, pretend it's there. Because it's going to be positive. And it's like, oh my gosh, what's the tangent line at this point? Boom, that's your tangent line. And all we did is we just found the equation of the tangent line. That's what linearization is for my caveman out there. Now, what is the application of this? This is when we start to get into linear approximations. So, what is linear approximation? Let's say I have the square root of 4. The square root of 4. What is the square root of 4, you might ask? 2. Now, how do we know easily what the square root 3.99 is? How do we know what the square root of 4.01 is? They're very close to 4, so obviously they have to be really close to 2, right? How can we estimate it without having to put it into a calculator? We can do this. We can take the root of x is our function. And if we put it on a graph, it looks something like this. Pretend that looks better than it does. X equals 4. Cool. And the answer is going to be 2. If we want to approximate the values that are close to this, like close to x but not quite, like they don't necessarily need to be on the curve, they have to be really close. What we can do is we can find the tangent line that's next to it. We can linearize this value. And so it's essentially like bending reality to say, what if to find the square root of something, it was a linear function instead of like this weird curve we had here. And so then what we end up with is we just do the same thing. Y equals 1 over 2 root x. And then it's 1 over 2 times 2 is 1/4. M equals 1/4. And that's going to be y minus 2 equals 1/4 x minus 4. And that's going to be 1/4 x minus 1 plus 2, 1/4 x plus 1. I don't think it actually explicitly states that in there. Oh yeah, I'm just making this up, I forgot. Yeah, 1/4 x plus 1, that's what the derivative is going to equal. That's the slope of this line right here. Y equals 4th x plus 1. Now, if we want to say, to find other values of x, we can pretend that this is the result of x on the inside of our thing. And we can be like, oh, y equals square root of blank value. Well, we can substitute this value of x, because this is x, like root of x, root of x, root of x. And we can come to our tangent equation and substitute it in and be like, okay, what is the value of it on that thing? 0.25 times times x, 3.99 plus 1, we 1.9975. So we can pretend that we now know that the root of 3.99 is approximately 1.9975. Same goes for this one. 0.25 times 4.01 plus 1, 2.0025. Now, remember, this is an approximation. This is not literally what the square root of 3.99 or 4.11 is. The square root of 3.99 is actually 1.997498, which rounds to 1.9975. They're very, very close to each other. And so we can infer that if we use our tangent line, we can approximate what value the root is going to be. But here's the catch. It has to be close. It has to be close to that value we chose. 4 is useful because if we want to know what the root of 3.99 was, we're like, oh, I know one that's close to it. 3.9, that's 4. So we can just do it for 4. But if you try and go farther, like if you choose a value like where x is equal to 18, then this is going to fall apart. Let's try it. 0.25 times 18 plus 1, saying that the square root of 18 is 5.5. Square root of 18 equals 5.5. Now let's actually get the square root of 18. Square root of 18 is actually 4.24. As you get farther and farther away, our approximation starts to fall apart. And that's the magic of this, is that when you're close, you can approximate, but when you're not, you're going to fall apart. So let's do some practice problems. Okay. Ooh, I smell. Okay. Dang, there's not a lot of practice on here. We're just going to pretend the one I did was a good practice. Okay. Verify the given linear approximation. No, I should not have that one right yet. That's when it starts getting errors. Let's go down to... Oh, yeah. Okay. We're going to stop here. I'm going to move on to a new topic.